everybody. It is Mike Levin on Sunday, December 5th, 2021. And I'm picking up my kid. And in fact, I'm probably more than halfway through the drive. It's about an hour and a half drive. And I didn't think I was going to shoot a video, but then I changed my mind because as these things race through my head, I'm like, how can I not talk about this? So out loud to myself to process the thoughts, but also to you, the YouTube audience out there, the general developer audience. It's interesting times. It's interesting times because Electron, the Chrome components platform, the free and open source parts of Chrome, which are part of the Chromium project, have been extracted into another project called Electron, which allows you to use the generic web components, i.e. the web browser that we're familiar with and love from a user interface standpoint. Maybe not love it, but you can do a lot in the web these days. You can do a lot user interface wise using a web browser with HTML and all the varieties of HTML, up to and including HTML5, which is almost an application development language in its own right, almost. So that kind of won, because that's being used. The ElectronJS package, the Electron platform is being used for Microsoft's VS Code. It's being used for Slack. It's being used for Discord and a bunch of other traditionally slow loading and painful to use sometimes interfaces, but that have been mainstreamed. So VS Code is a bit snappier, a bit quicker than the norm, and maybe Microsoft is showing, best of breed kind of example of if you're going to use Electron, look, it can be fast. Maybe they're saying something like that. Who knows? Maybe they're using their incredible amount of resources as Microsoft to just make it a particularly fast and responsive ElectronJS app. But whatever it is, it's time for me to find out for myself how good the ElectronJS platform is and variations thereof, because the big split is whether it needs to carry a copy of Chrome around with it, i.e. the formal ElectronJS package, and hand in hand with that carry a copy of NodeJS around with it, because Chrome components still need a web server somewhere in the picture. Something needs to be orchestrating the picture. So the front-end user interface, the Electron web browser components, have to be talking to a back-end web server type piece, i.e. NodeJS. And consequently why Electron apps have a reputation for being a bit bloated, because no matter how small and simple they are, they still carry around in their little directory, their bundled, packaged up directory, a full copy of Chrome that it likes to use for itself, and a full copy of Node and all the Node packages that have been installed in that same directory that it likes to carry, bundled all up there for itself. And so these directories get really big, and this development technique to do web development for the desktop gets a reputation for being a bit bloated and perhaps buggy and insecure. However, the Electron-Node combo is only one of such possibilities. And the other approach that kind of has me a bit excited about taking up desktop web development again for the first serious time since, I don't know, the VB6 days, Visual Basic 6. And on the Amiga computer before that, I did plenty of stuff with Amiga Vision and Can-Do and Scala, and probably a handful of others. And that's when, your lowest common denominator was still an Amiga computer. And the world has really just caught up with that, where the lowest common denominator is still a pretty highly capable, usually a game playing, a 3D rendered gameplay capable platform. Oh man, some people are zooming along here at like 90. Anywho, that's capable of running Chrome on, say, a modern Windows or a Mac or Linux desktop like Ubuntu. And so what you have now is those days that I remember from old, the Amiga, where you could learn, or on VB, on Windows, you could learn one user interface scripting environment, drag and drop, WYSIWYG sometimes, but it would get pretty broad potential deployment. Those days didn't last long on Windows for a variety of reasons, not the least of which Trojan horses and viruses were running rampant in those days, because these same easy abilities to create desktop apps that you can share was used to create viruses you could share. So that and many other reasons drove this movement sort of off the map. Also, heterogeneous hardware, many different platforms, iOS versus Android versus Chrome OS versus Windows versus Mac OS, and this incredible diversity, this heterogeneous mix of technology, meant that you couldn't write something once and target all platforms. You really can't even today with Electron, because it's a desktop biased technology. And I'll get to that in a moment, because I'm not letting that limit my thinking. Having something like an ElectronJS app that is also deployable to mobile is in the imminent future. And until it actually arrives, if not so imminent, it's in the inevitable future. But until that day arrives, we can just host the nearly web server version of the app that's currently running in desktop versions on desktops. So you take one computer somewhere and you designate it magically, you shall be the server. And instead of running the version of it that might pop up with a user interface, you run a slightly different version of it, probably the .py file, before it's all been compiled into a desktop app, or the .js file, whatever, JavaScript, Python. At this point, it almost doesn't matter the underlying, basically JavaScript versus Python and the matrix thereof. That almost doesn't matter, because everything will be able to be run either in an ad hoc way under a Jupyter notebook. Even JavaScript can run under Jupyter notebook. It's just a language plugin now. Jupyter has been opened to the JavaScript world. So if you wanted all the benefits of Jupyter, you just install the JavaScript plugin for Jupyter and you have it. But no matter what your coding language is, compiling it to a distributable exe essentially, but there'd be one for each platform, I'm sure. You compile it once in a way that'll work on Windows. You compile it once on a way that'll work on Macs, and once in a way that'll work on Linux desktops. So that's 3 versions right there you need to think about. And then a 4th version should run as a server somewhere, so that you have a way to do mobile. Mobile gets this app by hitting it over a web server. That has certain architectural implications, some design implications, specifically regarding accounts and logins. If it's a desktop app, well, there's a login. I guess there will be a login either way, and then all data that is stored down locally after that login has a choice of being compartmentalized, almost like session data that can grow real big with databases and stuff, but compartmentalized to that particular web user's login. So apps essentially have different local data stores depending on how you log in. So you always make login as part of even a web app. I know it can be a little inconvenient to occasionally be challenged for login, but most of the time it'll have an internal refresh token, and it'll just keep itself logged in even as you close the app, because controlling the app, you get to make those decisions. Sessions don't have to poof in between, say, closing browsers the way they do in web browsers. That's just a design decision. The forces that be, the people who made the web browsers, decided that when you quit out of your last window of your web browser, that session poofs away, and any cookies that have been written in such a way that they're only stored over session are erased. And that means log in too. That's why it's so common to have to log back in after closing your last web browser. Web browser window, I should say. You get the idea. And so we have different design decisions we can make when we say, oh, well, we're doing roughly the same thing, but the role of the remote web server shall be played locally by either Node.js when you're doing Electron and Node combo, and you're going the most industry standard way, and you have the support of the Node modules and that great JavaScript ecosystem, at the expense of a slightly larger app, maybe a little bit of responsiveness, when the alternative is to, well, there's a few alternatives, is to not carry your own Chrome around with you. Instead, you use whatever the operating system makes available as a default web browser user interface. That's how so many things are able to come up looking like web apps these days without even, it being an Electron app. It's just wrapping it in the Edge Chrome that's made available API-wise. So, you don't need Node in the picture. You don't even need Electron and Chrome in the picture. What you can have is GNU-corn. It would have in the past been called GNU-corn, but things are changing. They're going towards a asynchronous lean. So all the old acronyms we know in the Python world are changing a bit. So GNU-corn was an alternative, a free and open source web server, something to play the role of Apache more frequently these days, to play the role of Nginx, or to play the role of Node.js, frankly. It's a piece that is put in there in order to serve web pages to a browser. So if you're using components of Chrome to build your user interface, the price of that is to have a web browser in the picture. The web browser that's uber popular these days, that has a lot of support, high performance, you compile JavaScript code to run on it, is Node.js. Massively popular, highly recommended for front-end web development work. It has clearly won. Oh shoot. Watch where I'm going for a minute, because I don't want to get onto the George Washington Bridge. I want to get onto I-95 without going over the GWB, so I've got to be alert for a moment. That's the price of doing these YouTube videos while I drive and not editing. Sometimes I do have to pay attention to my driving. Yeah, I do believe all is good. But I do need to get back to where I was just at. Yeah. The different web server options. There's a web server built into Python. You don't even need any of this stuff. There's a one-line web server command you can trigger off. Now, bam, Python's working as a web server. However, it doesn't come with many of the bells and whistles that you expect, even in small local projects you're doing. So the common wisdom is to host your Python app that's running like a web server with some other tool. So whereas it's NodeJS in the JavaScript world, in the Python world, you have a lot of choices, as these things happen to be. And the popular recent choice up until concurrency was GNU-acorn. And I think it's GV-acorn? Unicorn, GNU-acorn, GV. It might be GV-acorn. But there's a new one on the block, which is just a concurrent version. So when you are writing your stuff against the asynchronous Python gateway to web protocols that used to be called Whiskey, you're now writing for ASCII. Okay, so it's nice to have another ASCII sounding thing in the acronym mix, because it's also that's what ASCII organization standards sound like. The original 256 ISO Latin 1 characters, those were roughly the ASCII character set that a lot of early home computers used. So this is a new ASCII we need to learn, and it's the asynchronous web gateway for Python. And you always make your Python code assuming it's going to be talking to something like that, you see, because it's a standard API. It's the way it's done in Python. And that means you can swap out web servers quite easily. And so one of the web servers you're going to be popping out is the modern concurrentized version of GNU-acorn, which gives a extremely lightweight alternative to Node.js, especially if JavaScript doesn't need to be in the picture. There is no reason you can't bring up, say, like the operating system's web API components and serve that from Python.exe that's communicating with web stuff through GNU-acorn, for lack of remembering that other one's name. And this comes into play when you use things like Dash. Dash is now supported and all the echoing. This is where I need to make sure I stay on the right thing, I-95 south, in order to get down to Staten Island. So you can mock up dashboards in a Jupyter notebook. I use Jupyter Lab, so let's say Jupyter Lab. You can mock up dashboards, full-fledged dashboards. 95 south, keep right. Mock up full-fledged dashboards directly in Jupyter Labs. That's an amazing thing. You can make interactive drop-down menus. Now, the Python world, through, mostly hearing about it through like the Talk Python to Me podcast, that's certainly how I heard about it, learned about Streamlit, a pseudo dashboarding technology which let you do data visualizations that came with sliders, little user interface widgets you could grab and move, and the visualizations would change, and that was pretty darn exciting. However, it was not quite mainstream enough or built up enough or dashboardy enough to confidently build business dashboards around. It just didn't feel like a component you would, give to your stakeholders and say, here's your report for today, and here's your slider to interact with the data. It was too D3 novelty-ish to me on first pass. Now that is not to say Streamlit isn't an excellent technology, but I didn't get excited enough to say, hey, let's build our dashboards with this. Well, one called Dash has now just hit Jupyter Lab from the company Plotly. Plotly is that company that does, dashboarding software for profit. They're a commercial company. However, they made an extraction that they made available to the free and open source world that's called Dash. And that Dash component has so much overlap with the Jupyter Lab world, the Jupyter Notebooks world, that they said, hey, can't we just make dashboards come up inside Jupyter Notebooks? Can't dashboarding be something inside a notebook? Especially with Lab, with this paneling system, you can have a dashboarding system that takes advantage of Jupyter Lab's panels, and you can have a paneled dashboard with your widgets over here and your dash unit over here. And in fact, that's the way it's bearing out. I'm having a little difficulty though getting the paneled version of Dash for Jupyter Labs to work with a panel mode, with the Jupyter Lab mode inside Jupyter Lab standalone edition. So I'm using the standalone version. It's, I guess, an important distinction. It's an ElectronJS app, another ElectronJS app that does all its communication with 0MQ. It's a very exciting architecture. I think even 0MQ for a zero latency messaging queue, like a high performance messaging queue between the components, because now there's front end and back end components that need to talk to each other. So messaging queues might be the way to go. Yeah, the type of technology I've stayed away from because tech liability, another server you have to set up and keep running. I hate that. Ugh. So things like message queues have landed in that category to me until I've looked at 0MQ. It's actually acceptable. It's doesn't have all the overhead of normal message queues, yet has most of the benefits. Perfect 80-20 rule solution. But when all your components are as tightly coupled as they are, sitting there in the same location, there may be things even lighter weight and lower level than 0MQ to do that communication, or to make communication altogether unnecessary. But no, you're still going to have some sort of JavaScript web framework talking to a Python backend. So you're going to have messaging. And those messages can be anything. Send HTML fragments around, and that's where HTMX comes into the picture. And those rectangular regions that you're using HTMX to be swapped out can be Vue.js components. So I have a vision of dashboarding that very much supports some technologies I am highly incentivized to stay compatible with, namely Vue.js. Now it's on Vue.js 2, and I'd like to get it to Vue.js 3. But however, I can lock versions of rectangular regions. I can say this rectangular region is Vue 2, and play a lot of shell games having to do with isolated scope from each other, little rectangular regions that can communicate with each other in various ways. Messaging is always a question, an issue. How does this rectangle here communicate with this thing here? Well, if it's all sitting in the same rectangle, then the controls can have direct control via JavaScript or whatever. And that's what happens with Dash when you use the Dash for Jupyter Lab in one of the 3 modes it provides: inline, server, or Jupyter Lab mode, which is in panels. The third way I haven't gotten done yet, but you can mock up dashboards and have those controls and slide those controls and change drop-down menus and see the changes on the screen twinkle and change before you. And then you can extract that and put it into something else, either a web-hosted app or something that installs locally on your desktop. Formal data pipelining. So another tech liability thing, the kind of stuff I have traditionally and very frequently stayed away from. I now am getting much more up close and personal with, because the overwhelming majority of opinion is that this is how you take it to the next level. This is how you mature this stuff. And they even have versions of it that are made for data science. Paying attention to driving has made me forget it, but I heard about it recently on, again, Talk Python to me. Turn off this light for safety in this driving. And then probably I'm going to switch my head fully in the game here. But anyway, that wraps it up at a pretty good place. I will entertain web development. Because things have just reached that point where it's almost a impossible to get away from thing. You know, call it an inevitability. It's pee in the pool of tech. Back in the day, it was PostScript to print out to laser printers. You didn't have to know PostScript. Things had to get sent to it. So in that sense, JavaScript has become the postscript of the new generation. The main way output is sent to a user and input is achieved from a user. Like laser printers suddenly became two-way. But I hold about as much excitement for learning JavaScript as I did for learning PostScript. They're both about that appealing to me. So whenever possible, lean on these things that are just printing out the PostScript, that are allowing you to continue to work in your favorite language, in mental models that you can wrap your mind around and be comfortable with, and spontaneously express yourself without the inhibition of always feeling like you're having to speak another language, a foreign language, to express yourself, which has always been the feeling with me, with tech, with programming languages, other than first VBScript and then Python. I never got into the zone, got into the flow, where I've stopped having to Google everything I was doing and just started knowing how to do things. So I've tried it a few times in the JavaScript world and have looked at these JavaScript client-side libraries that provide user interface widgets and session and communication, and have backed off of it again with the same vigor as I have backed off the first time. This is no better. Now that was React, the reaction to React, and subparts of React too that were not so hot. Ways I think that session were sent around. Redux, that reminded me a lot of reminded me a lot of view state in ASP.NET. ASP.NET had the view state variable, and that was just horrible. And this was horrible as well. So I backed off of React, and I'm looking more at Vue. I'm accepting Vue. Vue is not so objectionable that I have to, completely rewire my mind just so that I can use a framework. I think I can use Vue and maintain my sanity. But I don't want it to be the main thing about web development. I just want it to be optional things I can use in a rectangular region I plug in and swap around. So anyway, I'm going to wrap up there and focus fully on driving for the rest of the way. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.